Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, today we are focusing on this paper 5, which is S1 paper, and this is of October, November 2024. This is the second variant. Now, let's get started. Question number 1. It says at a college, the students chose exactly one of tennis, hockey, or netball. So there are three kind of sports, and that is tennis, hockey, or netball to play. And then it says the table shows the number of students in year 1 and year 2 at the college playing each of the sports. That means year 1 students, there are 16 students who play tennis. And let's say in year 2, there are 28 who play netball. So now it says one student is chosen at random from the 120 students. Event X and N are defined as follows. Let's get started. So now over here, it says X is the students in year 1. So now let me draw a line over here. That is students in year 1, that is 16 plus 22 plus 24. How much is that? So that is 22 and 12, 34, 16, 50. So there are 50 students in year 1. And then it says N is the student plays netball. And this is defined as X. And netball, that is this one, which is like this, going like this. And 12 plus 28, that is 40. This is for netball, and this is defined as N. Got the idea? So now it says one student is chosen at random from 120 students. X and N are defined as follows. X student in year 1. So if I write probability of X, that would be 50 over 120. And N is the student plays netball. So probability of N, that would be 40 over 120. And let me just write one other thing. There are 12 students from year 1 who play netball. So probability of X and N, he is in or she is in year 1, as well as plays netball. That would be 12 over 120. That I'll use up later for this particular part, which is part C. So now it says, find the probability. Now, what does it say in the first one? And what does it says in the second one? So now it says X slash N. Let me write this thing in words. What it says is that probability of X happening given the condition, given N has already occurred. That is the meaning of the statement, X slash N. What comes after the slash? Let me write over here. What comes after the slash? This thing over here, this N, that is this given thing, that N has already occurred. This is the condition. On the other hand, X is coming after N, and it's like this over here. So after the slash, N is there. Over here, given X has already occurred. That is the difference between the two. So probability of N happening or occurring given X has already occurred. Now, the working is for 1 and 1 mark. It's very basic, but the main thing is the denominator. So remember, when we talk about probability during our regular classes, the game is all about the denominator. You choose the right denominator, very high chances, very high probability. You choose the right numerator. So N has already occurred. So over here, 40 is the denominator. And this 40 is basically obtained by, let me shift this 40 on this side. Let me write equal on this. And how is this 40 obtained? N. So this 40 is obtained by two things, that is 12 and 28. So this is year 1, this is year 2, that adds up to netball. And what does it say? Probability of X happening. X is student in year one. So this 12 goes up, this 12 goes up. No need of reduction. Leave it as it is. That's the answer for the first part. Examiners are not obsessed with simplification of this. Leave the answer in the raw form. It looks beautiful. It looks exact. Now the next one, probability of n occurring given X has already occurred. So now X is this thing, that is year one student, that is 50, that's a combo of 16, 22, and 12. So let me draw a line over here and a small line over here. That is 16 and 22 and 12. This adds up to 50. This is basically, there are three sports: tennis, hockey, and netball. This is tennis, this is hockey, this is netball. Probability of n occurring. So therefore, this 12 again goes up. So this answer is 12 over 50. So now that is how this particular question is done. Now we are moving to C. There is C, there is D. Now this is like the first question has 4 parts. That's very strange, but expect the unexpected. So a lot of things that I would like you to focus, because the exams are right around the corner. That is, remember this rule, expect the unexpected. Every single year, every single paper that you do, that will look different to you because they are experimenting with it. So there is a lot of experimentation going on, and sometimes they can mix one topic with the other. So that is why expect the unexpected. That thing is there. Now determine whether or not X and N are independent. So I have probability of X. Let me highlight this. I have the probability of X. I have, let me make it bigger. This is probability of X. This is probability of N. And this is a combination of both, that is and. Independent events, statistically independent. If we say probability of A and B, if it equals to probability of A into probability of B, that is independent events. This condition has to be fulfilled. So probability of X and N, does it really equal to probability of X into probability of N? Check it out. Grab your calculator. This is 12 over 120. And probability of X is 50. This is 40. This is 50 over 120 into 40 over 120. Check it out. I don't think so. It's equal. So you would say, nope, it's not statistically independent. So that is the answer for this particular part. Now it says one of the students who plays netball takes 8 shots at goal. On each shot, the probability that she will succeed is 0.15 independently of another. So what does it sound like? This sounds like binomial. So now over here, let me highlight this. 8 shots, that's the number of trials. That's the first thing. The probability she will succeed is this much. Find the probability she succeeds on fewer than 3. First of all, we will write X follows, or since they have used the word, the letter X, let me write W. W follows a binomial distribution 8, 0.15. That is the probability of success. She will succeed on fewer than 3. Probability X is lesser than 3, does not include 3. Probability X is lesser than or equal to 2, which is a probability of 0, which is 8C0 and 8C1 and 8C2. So these 3 probabilities needs to be calculated. This is success 0.15, 0.15, 0.15. This is failure 0.85, 0.85, 0.85. And the success, this power 0 goes over here, this power 1 goes over here, this power 2 goes over here. And there is a difference of 8, and this is 7, and this is 6. So you write down all these 3 probabilities. Make sure to write down the answers. So therefore, this is 8C0, that is this thing, 0.27249. This is 8C1 thing that is coming out to be 0.38469. And this last one is 0.23760. So you add it all up, and this comes out to be 0.895, correct to three significant figures. That is the answer for this particular question. So that is question number 1. That is done and dusted. Okay, so let me just put this thing over here. Let's get started for this part. Now, this was also a nice question. Question number 2. So now question number 2, it says, find the number of different arrangements of all these options. So what are these options? I mean, that particular word, 9 letters of the word algebraic. So A, L, G, E, B, R, A, I, and C. So what we observe is that there are only 2 A's and the rest are all different. So the rest are L, G, E, B, R, I, C. 7 plus 2, that is 9. So this is 9 factorial divided by 2 factorial. So let's use the calculator. And 9 factorial over 2 factorial, 181,440. Leave the answer in this form. This is exact. Therefore, do not round off. We only round off if the answer is not exact. Be very, very careful. Now, this is for 1 mark. The next one is for 3 marks. The marks are a bit lesser in this one. Find the number of different arrangements of 9 letters of the word algebraic. It's about arrangement. The first one was also arrangement. Of the 9 letters of the word arrangement in which there are no more than 2 letters between the 2 A's. So what does it mean, no more than 2 letters? That means there is an option of 0 letter or gap. I think letter is better. 0 letter between A's. There is an option of 1 letter between the 2 A's. And maybe there is exactly 2 letter between 2 A's. So there are many ways of doing this. I'll just do the one which I find the easiest. Now, first of all, 0 letter between the 2 A's, that means the 2 A's are together. So now if the 2 A's are together, let me put them in a box. So this is 2 A's together. Let me draw a box around it. So therefore, there is a box like this. And there is an A, there is an A. And what are the letters? L, G, E, B, R, I, C. L, G, E, B, R, I, C. So 1, 2, 3, 4, 5, 6, 7, and this is 8. That is 8 factorial into 2 factorial divided by 2 factorial. Why are we dividing by 2 factorial? Because both are A's. So technically this is 1, this is 8 factorial. Therefore, this answer is coming out to be 40320. This is 40320. That is one part. Now, what about 1 letter between the A's? Now, let me do one thing. Let me write over here 1, and then a gap, and then an A over here, and then I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now look at the positioning. A is over here, A is over here, and the rest will fill up the space. Now change the position. This is first and third. It could be second and fourth. It could be third and fifth. Got it? It could be fourth and sixth. It could be fifth and seventh. It could be sixth and eighth. And it could be 7th and 9th. So just, I mean, that positioning is not giving you the marks. The writing down option is. That's 2 and 4. That's 3 and 5. And then that's 4 and 6. That's 5 and that is 7. and that is 6, and there is 8, and there is 7, and there is 9. So how many lines do you see? We see the following lines. That is 1, 2, 3, 4, 5, 6, 7. So this is for 7 lines. And the two A's, these two are fixed. That's 1, 1. So basically, the green ones are the ones that you are moving around. So the different options, so that is 7 factorial into 7 lines. Got the idea? So therefore, this is coming out to be 35280. 35280. You don't have to draw so many circles and things like that. Just play with it. So now I know the marks are lesser, and this kind of questions has appeared many times before, but that is usually like one part only. This is like this part and this part and this part. Now there are two alphabets. So now there are two alphabets. So therefore, this is A. And then let me put two circles, 1 and 2. And then this is another one like this for the A. And then 4 are used. So therefore, 5, 6, 7, 8, and 9. Got the idea? So therefore, this is A, this is A, this is 1, 2, 3, 4, 5, 6, 7. This time, this is first and fourth. Now it's second and fifth. This is third and sixth. This is fourth and seventh. This is fifth and eighth. And this is sixth and ninth. So again, how many lines do you see over here? You see line 1, line 2, line 3, line 4, line 5, line 6. So there are 6 lines over here. 7 instead of 7 in the previous one. There are 6 lines over here, multiplying with what? With the green one. That is again 7 factorial. So 7 factorial into 6, that is 30240. So we have 30240, we have 35280, we have 40320. So therefore, the total number of ways when I add it up, that is how much? 40320 plus 35280. 35280 plus 30240. Therefore, this comes out to be 105840. 105840. Again, this is exact, no need of rounding off. So I hope this is all good, all clear. I think there was already one over there, my bad. Let's move on. Question number 3. So now this thing is done. Let me move to question number 3. Now, this was even a better question. Now it says a fair coin and ordinary fair dice. So there is a fair coin. That is for this one. And then there is an ordinary fair dice. Fair 6-sided dice are thrown at the same time. The random variable x is defined as follows. So there are two options. The first option is this. If the coin shows a tail, x is twice the score on the dice. And if I focus on the orange one, if the coin shows a head, x is the score on the dice if the score is even. Score on the dice if the score is even, and x is 0 otherwise. Draw up the probability distribution table for x. Find variance of x. Let me just double check one thing. That is the recording and everything. Okay. So now it says, first of all, let me write over here, tail. The probability of tail is half. Let me write over here, head. The probability of head is also half. And then based upon that, later on, I'll add this up and make one table over here. So that table will come at the very bottom. That is after all the tough work at the top. So that would be over here. That is x, and probability x is equals to x. We will simplify things from there. And then when we talk about variance of x. We know that expectation of x is sigma px. That's not a big deal. We know that expectation of x square is sigma px square. And let me just, I have space over here. So let me move over here. And then at the very end, I'll have variance of x, that is expectation of x squared minus square of expectation of x, that is coming up later. So now over here, what we do is that when it's a tail, it's twice the score. So therefore, if I have, let me write over here 1, 2, 3, 4, 5, and 6. So over here, I'm writing the score. The score is 2, 4, 6, 8, and 10, and 12. So I'm focusing on the score. So that is this thing. So there is a 2, there is a 4, there is a 6, there is an 8, there is a 10, there is a 12. When it's about a head, again, let me write over here 1, 2, 3, 4, 5, 6. Now there are two options. If the score is even, score on the dice. If the score is even, so that means 2 will remain as 2, 4 will remain as 4, 6 will remain as 6. Otherwise, you are getting a 0, a 0, a 0, and that is how this thing is obtained. So first of all, 2, 4, 6, and then a 0, a 0, a 0. So both things are considered. Now, again, over here, the probabilities will be multiplied by half. Okay. So now what we can do is that this is, if I start with the smallest score, which is a 0. So I see a 0, a 0, a 0. There are 3 options. And these 3 options, so let me write, for example, probability x is equals to 0. That is half into 3 options. So that is like 3 over 6, 3 out of 6 from this one. So therefore, this is half into half, and that multiplies to give you 1/4 over here. Now, first of all, think about this and think of all the other options that will be occurring like this. So now this thing is coming out to be 1/4. Similarly, let me talk about 2. Probability x is equals to 2. So there is 1, 2 over here. And there is a score of 2 also over here. So this is 1 over 6 into half. This is 1 over 6 into half. So this is half into 1 over 6. And this is half into 1 over 6. The two halves are different. This is from the head thing. And this one is from the tail thing. So the tail one is this. And this one is from the tail thing. Got the idea? So that is half into 2 over 6. That's half into 1/3, which is 1 over 6. So therefore, this is 1 over 6. So you can even write in the 12 form. So this can be written as 3 over 12. That will be better. And this is 1 over 12, 1 over 12. That comes out to be 2 over 12. So let me write over here 0. What are the scores? Is there a 1? I don't see a 1. I see 0. I see 2. I see 4. I see 6. I see 8, 10, and 12. So 0, 2, 4. That is 0, 2, 4. That's the score. And 6, 8, 10, and 12. These are the different scores. So now, basically, you just have to multiply it with half for each of them. Don't forget that. This is 3 over 12. This is 2 over 12 because there are 2 options for the 2s. What about 4? 1 option, 2 option. So that is also the same thing. That would be 2 over 12. You don't have to do any working. So 4 is done. What about 6? So 6 is 1 option. 6 is the other option. That is also 2 over 12. Got this? And now for 8 and 10 and 12. So that is 1 option. That is 1 option. That is 1 option. Half into 1 over 6. That is 1 over 12. This is 1 over 12. This is 1 over 12. This is 1 over 12. Double check. So 3 and First of all, 2, 2, 2, 6, 6 plus 3, 9, 10, 11, 12, 12 over 12 is 1. All good, all clear. So that's how this working is done. So now let's move on. This thing is done. So now expectation of x, that is sigma px. Let me write it. That is 0 into 3, 2 into 2, 4 into 2, 6 into 2, 8 into 1, 10 into 1, 12 into 1, everything added together divided by 12, and then use a calculator, and this value is coming out to be 4.5 or 9 over 2, or 4.5 is also good. Expectation of x square. So that is 0 square into 3, 2 square into 2, 4 square into 2, 6 square into 2, 8 square into 1, 10 square into 1, 12 square into 1, divided by 12. And this comes out to be a big number, that is 35. Do double check my working. Expectation of x square, 35 minus a 9 over 2 whole square. That is 35 minus 81 over 4. And do the subtraction. Therefore, this comes out to be 14.34 or 14.75. That is the answer for the variance. Of course, the expectation and variance, that's all mechanical working. The main working is that probability thing. Question number 4. Let's focus on this one. For question number 4, read the question first. And hold for a second. Now, question number 4, it says the heights in meter of white pine trees are normally distributed. So this is white pine trees are normally distributed with this mean and standard deviation 2.4. In a certain forest, there are 450 white pine trees. How many of these trees would you expect to have heights lesser than 18.2? That's part A. And there is another kind of pine tree, that is the red one. So red pine trees are normally distributed. This is the mean. Standard deviation is sigma, unknown. 26% have heights greater than 25.5. Find the value of sigma. That is back solving. Okay, so let's get started. Pretty basic question. White pine trees follows a normal distribution. So this is normal, and that is 19.8, 2.4 square. Make sure to label everything properly. You have all the time in the world. Now it says lesser than 18.2. So probability W is lesser than 18.2. Probability Z is lesser than 18.2 minus 19.8 divided by 2.4. Probability Z is lesser than, yes, it will be a negative value. And this is coming out to be 0.6667, 0.6667. And don't forget the negative sign. Now, when we have a lesser than negative value, that is the same thing as probability Z greater than a positive value. Unless and until you make it positive, do not proceed. And then what's the next step? That is 1 minus probability Z lesser than 0.6667. 1 minus. Now you go to the normal distribution table and you go to the Z table and you use the p-value 0.66. That's for 3 decimal place. So 667, you have to read it. And this is the Z value, not the p-value. And therefore, the probability value that you are getting is 0.7477. 0.7477. So this is 0.7477. Do the subtraction, and this comes out to be 0.2523, and round it off 0.252, correct to 3 significant figure. Got the idea? So that is the kind of working. Yes, it's a good idea of writing equal sign because that is what is following, and that is the answer. every single step is necessary. So let me add a page over here, a small note that is show all steps. Nothing more to say. Now it says you have to do this part, which is this thing, find the value of sigma. Now this is the other one. Red tree follows a normal distribution, 23.4 comma sigma square. Probability x, actually no, it's not x, it's r, greater than 25.5 is 0.26. And let me just do one correction. Yes, I've written W, I'm writing R. Perfect. Now over here, when we are talking about back solving, what is the meaning of this word back solving? That is, let me go over here. And back solving means using the probability value to find the Z value. So now 26% is not the right value. So 1 minus 0.26 is 0.74. That is the probability. So when P is 0.74, go to the Z value. And this Z value is coming out to be 0.643. So that is coming out to be 0.643. Do double check. And I just remember one thing. Now, I was looking for how many of these trees would you expect out of 450. So one last part was left. That is expectation of X. That is NP. So this is 450 into 0.252. This is basically an example of ratios. So therefore, this comes out to be 113.5. Both answers are correct. Right 113, right 114. Both answers are considered correct. All good, all clear. So this is the probability of success. This is number of trials. So this is N and this is P. That is the expectation of X. Coming back to this. So now, first of all, reverse it. Probability R lesser than 25.5 is 0.74. Probability Z is lesser than 25.5 minus 23.4 over sigma is 0.74. Probability Z is lesser than a positive value is 0.74. This value is 0.643. Now, the rule of back solving is that if this probability is more than 50%, 0.5 and above, if there is a lesser sign, Z value is positive. So therefore, 25.5 minus 23.4 divided by sigma is 0.643. Make sigma the subject. That comes out to be 3.27, correct to 3 significant figures. All good, all clear? So now this is question number 4. That's done. Now let's look at question number 5. Read the question first, and then we will get started with this thing. Now it says the first part is again very basic. In a class of 21 students, what do we have? We have 10 violinists, and that's 10V, and 6G, G for guitarist, 5P, 5 for pianist. So let me write over here. The first part is basic, so I won't waste my energy on that. A group of 7 is to be chosen from 21 students. So now focus on this, a group of 7. A group of 7, and this is about combination. We already had a question about permutation early on, the algebraic one. Is chosen from these 21. The group will consist of what? The group will consist of 4V and 2G and 1P. The first part is very basic. That is this thing. First of all, that's the green one. Then there is the blue one. Then there is the red one. So therefore, we would choose 10C4 and 6C2 and 5C1. So grab your calculator and multiply. So 10C4, I think I'm just missing my calculator. It's not working for a second. Yeah, now I got it. 15750. 15750. Again, this is exact. Leave the answer as it is. Question number 2. Now, this is for 4 marks. That was for 2 marks. On another occasion, a group of 5. Now, it's no more 7. It is 5 over here. A group of 5 will be chosen from what? From the 21 students. The group must contain at least 2V, at least 1G, at most 1P. So there is at least, at most. Got the idea? So therefore, let me write over here the 3 options. This is how many are V? 10, 6, 5. So this is 10, this is 6, and this is 5. So this is V, this is G, this is P, this is 10, this is 6, this is 5. Now, there are different kinds of options. Let's say if I fix P as 1, and then it says at least 2 and at least 1. So 2, 1, 1. 2 can become 3 and 1 can become 2 because this is 3, 4, 5 and this is 2, 2, 4 and 1 this thing. So got the idea? So this is like this. These are 2 options that are very, very clear. What I did was that I fixed this thing up. That is, this 1 and 1 was fixed. I increased this thing. So therefore, over here, it was 2, at least 2. So I made it 3. And over here, I made it 2 and double check. So therefore, 2, 1, 1, that is 4. We need 5. So that is a gap of 1 unit. Let me add that 1 over here, or let me add that 1 over here. So let me write these 2 options first. So therefore, this is 10C3 into 6C1 into 5C1. I'll do the calculation later. And this is 10C2 into 6C2 into 5C1. I'll do the calculation later. So therefore, this is 311 and 221. These are 2 options. What about if I fix these 2 as zeros? I can also do that. If I fix these 2 as zeros, that means I need to collect 5 from these 2. That means, can I choose 3 and 2? That is a possibility. Can I choose 2 and 3? That is also a possibility. Can I choose 4 and 1? That is also a possibility. So let me add one more thing. So therefore, another 0 over here. And this is, first of all, let me write with the biggest one. This is 410. So therefore, this is 10C4 into 6C1. And the last one, 5C0. Even if you don't write, doesn't make a difference, but just go with the flow. And then a 3-2 and then a 2-3. Got it? So that is 10C3 into 6C2 into 5C0. And that is 10C2 into 6C3 into 5C0. So 410, this answer is 1260. And 320, this answer is 1800. 230, this answer is 900. And then the top one, 311, that is 3600. And then there is 221, that is 3375. I think these are all the options that are possible. So therefore, the total number of ways is adding all of these 10935, 10935. That is again exact. Leave the answer in this. So therefore, this thing is all done, all clear. And let me write something over here. And let me add this thing over here. Now, that's something that I want to write over here. When you are talking about combination, especially in such a group formation, first write it out and then focus on calculation. So then focus on calculation. Write it out. That means write out all the options. So that is this option, all this thing. First, focus on this. This is what you need to focus. This is just mechanical work. Got it? So 5 questions are down. Now, the other questions, I have already done it. So now let's look at this. It says a team of 15 runners took part in a charity run last Saturday. The time taken in minutes to complete the course by the runners from the Falcons. So there are the Falcons over here and the runners from the Kites. These are the Kites people is over here. Draw a back-to-back stem plot to represent this information. So Kites is on the right with Falcons on the left-hand side. So Falcons are over here. So therefore, this is Kites and this is Falcons. So now, first of all, make sure the data is arranged in ascending order. 38, 39, 42, 44, 46. Yes, they have already done the good part for us. The same goes for Kites. So now choose a simple scale. 32. So there is a row of 3, a row of 4, a row of 5, a row of 6, a row of 7. So 3/2 means 32 for the Kites. 5/4 because it's on the right hand side. So let me focus on this. For this 4, 5/4, that means 54 for the Kites. And 5/1, 1/5 is 5/1, that is for the Falcons. So a single key would do the job. If you want 2 keys, you can write 2 keys. That's not an issue. And that's how everything is filled up. Now, let me just do some clearer up work. Okay, so this is the stem, the one in the middle. This is the leaf, and this is the leaf. And the chances are they would be asking for median and quartiles, and usually from the left, they are asking. There are 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know that 15 divided by 2 is 7.5 rounded up. That is the 8th value is the median. So let me focus on the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. So 1/5 is 15. That's the median. And from the lower 7, let me write over here like this. T8 is the median. There are 7 values on this side, 7 values on this side. That means the 4th smallest one is the lower quartile. The 4th from here, that would be the upper quartile. That's how I do it. So now this is 1, 2, 3, and this 4. That is lower quartile. And therefore 1, 2, 3, and this 4, 9/5, 59. That is the upper quartile. So therefore, it's all over here, 51 and then 44 and then 55. Interquartile range is the difference between the two. Basic thing. Now, this thing, that is about mean and standard deviation. It says let X and Y denote the time for Falcons. So X is for Falcons. I think Falcon was red and Kites was blue. And this is the information for the Falcons. This is the information for the Kites. Sigma x squared, sigma y squared. Find mean and standard deviation of the times taken by all 30 runners from the 2 teams. So W is x plus y. Therefore, sigma W is sigma x plus sigma y. Number total, that is 30. W bar, add these 2 divided by 30, that is 52.5. Again, this is exact. That is W bar. So let me highlight over here, that is 52.5. And sigma W square is just adding this plus this, and that is over here. So let me write over here, that is sigma W square, that is 85727. And sigma W was, let me just shift this down a bit. Sigma W is 1575. So we use this and this, we find W bar. We use the whole formula, sigma W square. If you want me to write it, I can. So therefore, SD square for W, that is sigma W square over NW minus X bar, actually W bar square. And then we plug in the value, which is over here. This is this much. 30 was there, 52.5 was calculated. We get this thing. And therefore, standard deviation at square root of this is given correct to 3 significant figures. So that is also pretty basic. Question number 7, that was a nice question. And over here, read the question first. Now the question is about binomial, and the question is about a geometric maybe. So now it says, in a game, players attempt to score a goal by kicking a ball into a net. The probability that Lino scores any goal is 0.4 independently or of all other attempts. Now, when we talk about geometric, there is no number of trials. And in binomial, there is number of trials. They are independent of one another. Also, the probability thing, if it's independent, you can multiply it out. The random variable x denotes the number of attempts that it takes Leno to score a goal. Find the probability x is equals to 5. First, describe that this is a geometric probability distribution. That's the first thing. And then the next thing is that probability x is equals to 5. There is only one success and 4 failures. So you can leave the answer in this exact form. You can leave the answer in this exact fractional form. Now, this is the first part. Now, probability x lies between such and such. Now, this part over here, this can be done in different ways. So let me write over here this as method 1. And then I might tell you method 2 and 3 also. Find the probability x lies between 3 and 7. So that is 3, 4, 5, 6, 7. There are 5 probabilities to calculate. Probability x is equals to 3, 2 failures, 1 success. Probability x is equals to 4, 3 failures, 1 success. X is equals to 5, 4 failures, 1 success. Similarly, 5 failures, 1 success. Similarly, 6 failures, 1 success. And then when you add it up, what I did was that I took 0.4 common. I took the lowest one, 0.6 square common, just for simplicity. And then I get this answer. This answer is also exact, a little bit lengthy, but exact. Now, let me focus on what are the other methods. And those methods I've done over here. First, focus on this one. This one over here is that we have this formula. Let me write over here. Probability x lesser than or equal to n, it's 1 minus q raised to power of n. Very famous formula. So now probability x is less than or equal to 7, 1 minus 0.6 raised to power of 7. Still, I haven't used the calculator. Probability x is less than or equal to 2, 1 minus 0.6 raised to power of 2. So this is 7, solid circle all the way down. This is, let me draw it. I think it would be a good idea to draw it. So over here, let me draw the number line. Let me draw a line like this. Let me draw a line like this. Now, first of all, like this, solid 2, solid 7. And think about it. This is probability x is lesser than or equal to 7. This is probability x is lesser than or equal to 2. So when I subtract, what will I get? I'll get 3, 4, 5, 6, 7. These are the ones that are left. Got the idea? That is what I've applied over here. So this 1 and 1 cancel out. Minus and minus makes this plus. 0.6 square is positive. 0.6 raised to power of 7 is negative. These are the exact values. This is the answer, just like that. And the third part is the most interesting one. When we have a geometric probability distribution, it's called geometric for a reason. If I have the first term as A and the second term is AR and third term is AR square and AR cube and so on, can I list down the possibilities over here? So over here, we have these things. Can you focus? Doesn't this thing, this is like a and this is ar squared, this is a and this is r cubed, this is a and this is r power 4 and so on. So therefore, the probability of success, I think point 4 is the success, right? Yeah. Probability of success is a and the probability of failure is r. Keep that in mind. So now over here, probability of success over here, probability of success is like A and probability of failure, it's like R. So now what I've done is that I've calculated the probability x is equals to 3 because they're not asking from 1 till 7. They're asking from 3 till 7. So this term over here, that is your first term. Common ratio is the probability of failure. There are 5 terms. I use the sum formula. I get this answer. So this is like way out of box. So of course you can do it. I would prefer that you either use method 2 or you use method 1 over here. So these are the 2 different methods that is most easier to manage. So therefore just use this thing. And then we add it all up like this. Okay. And that's how the answer is obtained. All good, all clear? And now just the last part. Now, this kind of question was asked before also. Find the probability that Leno scored a goal on or before his 5th attempt. So this is a combination of binomial and geometric. But the question was just like this on his 5th attempt. If the question was like this, then we would say, let's isolate 4 attempts and the 5th attempt is a success. And out of these 4, we use binomial. You can check out, I think it was in this paper. Do check this thing out. The previous paper that I used, there it is. Find the probability Nicola obtains a 6 for the 2nd time on her 8th throw. So the 8th throw, that is success on 8, that is geometric, just as it is. And out of these 7, you use binomial. So which paper is this? This is October, November 2024, variant 51. So remember this paper. And if anyone has not watched the video as yet, do go ahead and watch this video so that you would have a clarity in working with this. And it also appeared, I think, last year also. Now it says Leno scores his 2nd goal on or before his 5th attempt. What if the 2nd goal is on the 2nd attempt? That means the first is success, 2nd is success. That is simple, straightforward. What about he scores a goal on the 3rd attempt? So this is the 3rd attempt. And out of the first 2 attempts, what is happening? We are applying the concept of binomial. So we are applying the concept of binomial. We are saying that 2C1, 1 success, and probability of success raised to power of 1, probability of failure raised to power of 1, and this is the answer. That is for this thing. Similarly, over here, on the 4th attempt, so this is the 4th attempt, and out of these 3, what is happening? Out of these 3, again binomial. So this is binomial, this is binomial. Actually, this is also binomial. How? Because it says 1C1 and this is success raised to power of 1, failure raised to power of 0. That is this thing, but it was so basic that we wrote it directly. Technically, that is also considered binomial. So therefore, this is the thing. And last but not the least, that is on the 5th attempt. So therefore, this is the 5th. And out of the first 4 attempts, this is binomial. This is binomial. This is binomial. This is binomial. So that is how you write down all the options. And this was October, November 2024, variant 52. Very nice question. So wait a minute. I think there is one part that is left. And that is right over here. So now it says Leno, his attempt has 75 attempts to score a goal. Use a suitable approximation. Find the probability. Lino scores more than 28 goals but fewer than 35 goals. So now the probability of success is the same as before, which is what? Which is 0.4. And now the number of trials is 75. And now it's about suitable approximation. So what needs to be done? Number of trials is 75, probability of success is 0.4, probability of failure is 1 minus probability of success. Calculate three things. What are those three things? The first thing, that is NP. The second thing, that is NQ. The third thing, that is NPQ. Always justify the approximation whether the examiner asks for it or not. So we would write, since NP is greater than 5 and NQ is greater than 5, therefore X follows a normal distribution NP comma NPQ. Now what is NP? That is 30. What is NPQ? That is 18. NP stands for mean. NPQ stands for variance. So therefore we write 30 over here, we write 18 over here. And what else is there? The next thing is X lies between 28 and 35. This is normal approx to binomial. That means binomial becomes normal. Therefore don't forget continuity correction. So what we do is that we take the lower class boundary, upper class boundary of 28. We take the lower and upper class boundary of 35. Neither is 28 inclusive nor is 35 inclusive. So therefore we choose the red line in both cases. This line pointing towards the right, greater. This line pointing towards the left, lesser. These are the two values after continuity correction. It's a good idea to show it like this, that continuity correction has been done. Standardize and we get this particular value. Standardize and we get this particular value. This is rule number 7. When one z value is positive, the other is negative. What is the rule? Read the table for one value. Of course, discard the negative sign. Read the table for the other value, add the probabilities and then subtract 1. This is the answer, 0.494. They're asking for the probability. So now October, November 2024 with variant 52 is all done and dusted with flying colors. Take care everyone. Stay tuned for more content on mathematics with Shahab Yaqub.